4 objectives today, and they're at the top. 1, I need to remind you that you have to watch some videos this weekend. There are 4 of them to watch. I apologize if you were in my class yesterday. I lied to you. I said that each video was 5 minutes long. That was a bold-faced lie. The first video is only 2 minutes. The other 3 are 8 minutes. So, yeah. But it still is only 1 example each, but we're going through time to watch through it and stuff like that. So instead of it being 20 total minutes, it's 26. Probably it ends up being close to 28 total minutes of viewing time. I am sorry for lying to you today. I feel really bad, can't you tell? And so to make up for it, today when you leave, I will be offering free high fives. Okay? I didn't last that. I had free high fives and free hugs in the last class. You want to do? I offer free hugs too. Okay. Second, if you haven't done so already, your cone lab is due today. Please turn that in at some point in time before you leave. Third, I've got 3 slides of notes that I would like to do today. And lastly, I have another homework sheet to hand out to you today. Okay? All right? So that's my 4 objectives today. Okay? So let's start with this wonderful warm-up problem here for you. Go. Side note, it might help to have your pink sheets out. Apparently there is a rumor circulating around that we're making you memorize the pink sheet. Nothing could be further from the truth. Yeah, that's why we gave you the pink sheets, so that you could use said pink sheets. Yeah, we made you memorize the unit circle. I'm not going to make you memorize all 26 formulas, especially those last 3. Is that what you got? Yeah, because that's what you should have gotten. Get out. All right. Because what? Go for it. Talk to me.
I don't know if this is right, but the cosecant
Yep.
sine x
Love it.
times cosine x times cosine over sine x.
Okay. So then you said that this then was cosine of x times cosine of x over sine of x.
Yeah.
And then did you simplify that purpleness?
Yeah.
To what? No. No, I simplified it to cosine squared. I went to that. Common denominator? YB? Maduz. YB is yeah, buddy.
Okay.
Then? Then what?
Isn't it 1 minus cosine squared x times
Sine squared, yep.
Sine squared or sine.
Sine squared over sine? And that simplifies down to be sine of x. Yes? Questions, comments, concerns? Huh? Moments? None? Let's do it. Yes. So so on this one, what I would do is I would multiply the top out. So I would get 1 minus cosine squared of x on the top. One minus cosine squared x on the top is sine squared. Sine squared divided by sine is sine of x. Yes? Love it. I do the exact same thing over here, except I would get secant squared of y minus tangent squared of y, and all of that would still be over secant of y. Secant is tangent squared of y plus 1 . That gives me just 1 over secant. 1 over secant is like 1 over cosine, which is just cosine. Questions, comments, concerns? Moments. Just when you thought you were getting the hang of it, what do? Gesundheit. I go and I ramp it up a notch. Oh, yeah. With numbers, sister? Yeah! Oh, yeah! So, now, let's take a little moment. Let's take a little step back. Let's think a little bit, okay? Because you see 3 cosine of x minus 2 equals cosine, and all you want to do is just throw in the towel. Send an email. Get me out of this class. Okay? Now, I put a think box on there for a reason. This first one is no different than 3y minus 2 equals y. What would you do to solve 3y minus 2 equals y? Okay, how are you going to do that? Subtract 3y from both sides, right? So then that gives me negative 2 equals negative 2y. Divide both sides by negative 2. And you get 1 equals y. Right? That's no different than over here. That's as hard as it gets for now. Okay? Okay? No. Okay? So over here, I'm going to subtract 3 cosines. That gives me negative 2 equals negative 2 cosine of x. Divide both sides by negative 2. That gives me 1 equals cosine of x. Right? Now, here's where this part right here, actually not even so much that part. That part right there comes into play. So where from 0 radians included to 2 pi radians excluded, so first lap of the unit circle, where on the first lap of the unit circle is cosine equal to 1. 0 and 2 pi, right? Okay. But this is saying right here that I'm not including 2 pi. So the answer would just be 0. So x equals 0. Now, what if it had been x equals the square root of 3 over, excuse me, what if it had been cosine of x equals the square root of 3 over 2? Then it would have been what? Pi over 6 and 11 pi over 6 would have been both of them. Because at both of them, x is square root 3 over 2. Okay? Go for it.
Yes.
I don't like it either. But it's a really good one. Almost as good as 21. So it comes after 20.5. 20.6. But it'll be 21. It'll be okay. First off, I would find me, so I would go minus 2. And then I would go minus cosine. We're smart enough mathematical wise, we can do that all at the same time. That would give us 2 cosines of x equals negative 1. Then I would divide both sides by 2, and that gives me cosine of x equals negative 1/2. And then I would ask myself, where on the unit circle is cosine? Negative 1/2. And I would say 2 pi over 3 and 4 pi over 3. One more?
No.
Yes!
I know, but I don't want to.
I don't want either. Let's do this one.
Wait, okay.
Again, ramping it up a notch. The videos that you have to watch this weekend ramps it up even more. Why are you gonna throw stuff at me? I'm just giving you math to do. Okay? So that's why the videos are important, because those deal with multiple trig functions in the same problem, and they also deal with that dreaded F word. First, subtracting 1 gives me square root 2 times the sine of x equals negative 1. Then, some people squared, and that's fine. That's going to Mosinee through Marathon. That's okay. We can do that. Okay? Or we could just divide by the square root of 2. That gives me the sine of x equals, now in my brain over here, I'm thinking that this is going to be the square root of 2 times the square root of 2 over the, you know what I mean? I'm rationalize my denominator. That gets me negative square roots of 2 over 2. On the unit circle, first lap, where is sine now equal to negative square root 2 over 2? That happens at 5 pi over 4 and 7 pi over 4. And those are your answers. Okay. Logan, I'm going to use you as an example. You over here, up here, squared. Right? So then you got 2 sine squared of x equals positive 1. Right? Then you divided by 2, or should have divided by 2, and gotten sine squared of x equals 1/2. Right? Then you would have had to have square rooted both sides and gotten sine of x equals plus or minus the square root of 1/2. Okay? What? Then what? Well, then this would have been sine of x equals plus or minus the square root of 2 over 2. So you would have gotten all 4 of them. Yes, because I only want 2 of them.
So what if you found those and then went back to the restriction?
Then what you'd have to do is you'd have to go back to the original problem and see if they work or not. And these 2 would have been kicked out. Then you would have gotten it. Okay? Because if I put those 2 in there, I would have gotten 1 plus 1 is 0. The other 2 that are left, I get negative 1 plus 1 equals 0. Okay? Good? So I have a second gold sheet to hand out for you now. It is 2-sided. The front side is all identities and just simplifying like we started yesterday and kept doing today. The back side is solving. I would wait on the back side until you've watched all the videos first. Okay? If you get to it this weekend, that's fine. If you don't get to it, we can get to it next week, Tuesday. Okay, the back side. But for sure, you have enough information to do the front side of said worksheet.